in we've talked about tangent lines before. What do we know about tangent lines so far? What's something you remember about tangent lines?
The slope of the point.
So the slope of the tangent line is the same as the slope of the graph at that one point?
Yeah.
Kind of saying what you're saying. Yeah, the slope of the tangent line should be the same as the slope of the graph at that one point. Going off of that, how many times would a tangent line intersect the graph? How many places would a tangent line intersect the graph? Secant lines go through twice, tangent lines go through once at the point of tangency. So I want to take that information and apply it here. Find the equation of a tangent line to our function f of x equals 4 over the cube root of x squared at the coordinate 1, 4. On the Desmos graph on the television screen, I have the graph of 4 over the cube root of x squared and the coordinate 1, 4 on that equation labeled right here. I can kind of picture almost what this tangent line might look like. Because after what Hunter said, I know that the slope of the graph and the slope of the tangent line should be equivalent. The tangent line I'm going to graph should almost look something kind of like this. It's like that tangent line just kind of skims right off the top of it. Touches it ever so slightly at that exact point. I know my line has to pass through what point? Okay, so my tangent line has to go through the coordinate 1, 4, because that's where it intersects the graph, obviously, right? Thinking about writing equations of lines, what else would be important to know besides a point that the line has to pass through? Could find the y-intercept, sure. Got to know something before I can do that, though. What else would be important to know about the equation of my line? About my line in general, what I probably need to know. Sure. When you were thinking about equations of lines, what's something that you're always usually asked to find? Besides like intercepts? Slope. I need to know what the slope of this tangent line has to be. The slope of the tangent line should be the same as the slope of the graph at this one point. How can I find the slope of the graph? What would I need to know first? What tells me the slope of the graph? Which function tells me the slope of the graph at any point that I want? That's the equation of a line. I'm going to use that here in a minute. I want to find the slope. I want to find the slope of the graph at one point. What type of function will tell me what the slope of the graph is at any point that I want? Take a look. Derivative. So I need to find the slope of my tangent line, which is the same thing as the slope of the graph at the coordinate 1, 4. Don't I need to find the value of the derivative at this point? So let's do that. Kind of part 1 here. Find the slope of the tangent line. How do we do that? Like we just said, we need to know what the derivative is, and then we need to find the value of the derivative at x equals 1, our point of tangents. I've got my function, f of x equals 4 divided by the cube root of x squared. Let's write that as 4 times some power of x. Is the cube root of x squared, is that x to the 2/3 or is it x to the 3/2? I'll write it as a power.
2/3.
2/3. Since it's in the denominator, it's going to be x to the negative 2/3. I'll write this in exponential notation using 2/3 as the same thing as the cube root of x squared. Since that's in the denominator, let's make that a negative x. Now we need to find the derivative. What is f prime of x? What is the derivative of function f of x? This will be the equation that will tell me the slope of the graph at any one point that I need. So bring down the 4. What's the derivative of x to the negative 2/3? Use the power rule. Okay, so what is negative 2/3 minus 1? That's the question right there. What new exponent replaces negative 2/3? What's 1 less than negative 2/3?
Negative 5.
Think of a common denominator. 1 is the same thing as 3/3. Negative 2/3 minus 3 more thirds would make negative 5/3. All right, so that looks really messy. Let's clean this up. Negative 2/3 times 4 is negative 8/3. I've multiplied 4 times negative 2/3 to make negative 8. Let's also kind of rewrite or simplify the negative exponent. Where's the x to the negative 5/3 going to go to become a positive exponent back again?
Mr. Lamori, please report to the secondary office. Mr. Lamori, report to the
Negative
secondary
8
office.
over 3x to the 5/3. If you want to keep it back in exponential notation, that's totally fine. Or put it back as a root. Negative 8 over 3 cube root of x to the 5th. Both of those are this. One's written as a power, one's written in radical.
Would you split the negative 8? Because I thought that was like a term by itself.
This is just a constant. Negative 8/3 is just a constant. So all I'm doing is I'm just adjusting this negative exponent to make it positive back again. So this negative exponent goes back down to the denominator. Is that what you're thinking of? This extra negative kind of confuses people sometimes. What's the negative exponent? Is it the negative 8/3 sign or the negative 5/3 power? What has the negative exponent I'm trying to get rid of? The power, right? This is just the sign. Signs can be negative, that's no problem. Negative exponents needed to change back to a positive, so we can simplify it a little bit more. Okay. Here's a function to find the slope of the graph at any point that I want. What's the point that I need? 1. So I plug in what for x? To find the slope of the graph at this point, what do I plug in for x? 1. F prime of 1 will tell me the slope of the graph at the coordinate 1, 4. Negative 8 over 3 times the cube root of 1 to the 5th. What's the cube root of 1 to the 5th? Start there. 1 to any power would be 1. What's the cube root of 1? 1. 1 to any power is just 1. So this would be negative 8 over 3 times 1, which is just negative 8. I put my ruler back up here again. I now know that the slope of this tangent line, the slope of this line as I'm making with my ruler right here, has a slope of negative 8. Found the derivative, plugged in 1 to find the slope of the graph at x equals 1. Let's finish this up in part 2 by writing the equation of our line. Since I know the point that my line passes through, as well as the slope of the line, I can use point slope form to write my equation. That would be y minus y1 equals m the slope times quantity x minus x. We're going to plug in our slope. We know that needs to be negative 8/3. What point does my line also pass through? What point should my line also pass through? 1,4. X1 is 1, y1 is 4. Here was the slope, or m. Here is the coordinate, x1, comma. It's called point slope form because it's defined for a point on the line as well as the given slope of the line. I know a point on the line is 1,4. I also know the slope of the line. Let's plug it in and write our answer. So y minus the y coordinate for the line of 4 equal to negative 8/3 times x minus the x coordinate of 1. That's a linear equation. It's just in point slope form. You can certainly leave it like that if you prefer. You're totally fine. I kind of like to solve for y to put it in slope intercept form, just out of habit, to get y in terms of x. So let's solve for y, essentially. I'm going to take negative 8/3 and distribute. So negative 8/3 times x. Negative 8/3 times negative 1 is positive 8/3. Bring down the y minus 4. On the left. Y minus 4 equals negative 8/3 x plus 8/3. Solve for y by doing what? F. See, y equals, once I add 4 to each side, negative 8/3 x. 4 in terms of thirds, that'd be 12/3. 12/3 for 4 plus the other 8/3 makes 20/3. If I graph that line up on the screen for Desmos, is that the tangent line? Does that look like what it should for the tangent line to the graph? It passes through the curve at 1,4 and just kind of skims right off that surface, doesn't it? Like if I zoom in, isn't the slope of the graph and the slope of the line pretty much the same thing? So it just kind of nicks right off the graph. Right there. All right, let's try this. Grab your laptops, please. And get on to Schoology. Let's open up the Unit 2 S7 practice.